Hello students, welcome to the CBSE Chemistry lecture series. Last video we discussed the colligative property of osmotic pressure and few NCERT problems. Now in this lecture we are going to discuss about the abnormal molecular mass. Yes, abnormal molecular mass. So before discussing the abnormal molecular mass, so the last videos we had derived the various colligative properties like lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressures. Various relations we have derived only for the non-electrolytes. Only for non-electrolytes. What is the examples for non-electrolytes? Say for example, urea is a non-electrolyte, glucose, sucrose, etc. These are all called non-electrolytes. When we suppose if it is a electrolytes, suppose if it is an electrolyte like sodium chloride, potassium chloride, here these are all undergoes a dissociation like Na plus plus Cl minus. It gives a two particles. That means the colligative property depends on the number of particles present in it. So the observed colligative property is double, and the molecular mass is half of the things. So from that we can arrive that colligative property is inversely proportional to molecular mass of the substance. Similarly for association, so this is for what? Dissociation. Similarly for association, say for example acetic acid, if it is a acetic acid, if n molecules of acetic acid will be, what will happen? Will be associated to give a 1 by n molecules of acetic acid. That is due to dimerization. So in these cases, the colligative property here it is what? Lower, whereas in the previous case it is a dissociation. If it is a doubled, molecular mass is half of the things. Here it is what? So colligative property is lower and the molecular mass is higher than the expected values. So here we are in a situation to define what is meant by molecular mass. So molecular mass, so here we have to define what is a molecular. When the molecular mass of a substance determined by studying any of the colligative properties comes to be a different value than the theoretically expected values, then the substance is said to be abnormal molecular mass. Abnormal molecular mass. So first of all you have to know what is by abnormal molecular mass. When the molecular mass of a substance determined by studying some of the colligative properties like what? Osmotic pressure, elevation boiling point, depression freezing point, comes to be a different value than the expected theoretical value, then the substance is said to be abnormal molecular mass. To find that what? To calculate the association or dissociation, Van 't Hoff is a scientist, introduced a factor called I factor. What is meant by I factor? I factor is nothing but expected colligative property by experimentally determined colligative property by calculated colligative property. Or otherwise, this is what I already told you, the colligative property is inversely proportional to molecular mass. So if I is equal to normal molar mass or molecular mass by abnormal molar mass. Suppose if the substance is what? Undergoes either association or dissociation. So in that case we have to modify the previous expressions for the colligative properties. How we can modify it? For lowering a vapor pressure, so P naught minus P by P naught is equal to chi2. We have written the relation for this lowering in vapor pressure. In that case, you have to modify the factor. If it is an abnormal molecular mass, means you have to introduce a factor called I. Suppose if it is a elevation in boiling point, delta TB is equal to I into Kb into molality. If it is a depression freezing point, delta Tf is equal to I into Kf into m. If it is osmotic pressure, pi is equal to I into CRT. In all the cases, we have to introduce a factor called Van 't Hoff factor for electrolytes, whether it undergoes or dissociation, whether it undergoes association or dissociation. In that case, you have to introduce a factor called I. Suppose if it is a degree of dissociation that is determined by the value, letter alpha. Alpha means if it is a dissociation, you have to use the formula alpha is equal to I minus 1 by n minus 1. The I is a Van 't Hoff factor and n is the number of particles present in it. Number of particles. Suppose if it is if you want to find out a degree of association, so in that case you got to use the formula alpha is equal to 1 minus I n by n minus 1. If you use this formula, we can find out the degree of dissociation. Once you know the degree of dissociation, suppose if in any problems, if you want to calculate a dissociation constant Ka, C alpha square by 1 minus alpha. Here C is nothing but molality and the alpha is what degree of dissociation or resolution, and this Ka is called dissociation constant, where Ka is known as dissociation constant. Yes, let us define or let us discuss the NCERT exercise problem 2.32. Calculate the depression freezing point when 10 gram of alpha chlorobutyric acid is added in 250 gram of water if Ka dissociation constant is 1.4 10 to the power of minus 3 and the depression freezing constant, that's what molar depression freezing constant is 1.86 Kelvin kilogram per mole. This is for a constant value for water. So what are the data given here? First you have to write the given data. So W2 is given. W2 is given as a 10 grams and W1 is a 250 grams and Kf is equal to 1.86, which is a constant for water, and Ka is also given as a 1.4 into 10 to the power of minus 3, and they are given a alpha chlorobutyric acid. So you got to write the butyric acid CH3 CH2 CHCl COOH. So this is a functional group. Next carbon is known as alpha, this is beta, this is gamma. So alpha chlorobutyric acid. So this will be dissociated into what? CH3 CH2 CHCl COO minus plus H plus. Okay. So if you want to calculate the molecular mass of this substance, M2 is nothing but 122.5. So everything is given. So first you want to find out the molality. Now what is the formula for molality? M is equal to W2 by smaller m is equal to W2 by M2 into 1000 divided by W1 grams. You substitute here, W2 is given as a 10, molecular mass is 122.5 into 1000, and W1 is what? Grams, 250 grams. First you have to find out the molality. So you have to cancel this one. This is what? 4 times. So you have to simplify it. We are getting a 40 divided by 122.5, which is equal to 0.3264. This is a molality value. Once we know the molality, we have to find out the Ka, that is the dissociation constant. So you have to modify this one. Ka is equal to C alpha square by 1 minus alpha, or you can say C alpha square is equal to Ka. When this alpha is very small when we compare with 1, therefore it is neglected. So alpha square or alpha is equal to square root of Ka by C. You substitute the values. Ka is what? 1.4 into 10 to the power of minus 3 by molality is what? 0.3264. If you simplify it, we are getting the value of 0.065. So this is the alpha value. Then if you want to find out a alpha is equal to I minus 1 by n minus 1. So we have to find out alpha we know and number of particles we know. So here we have to use it what? I. So I minus 1 is equal to alpha into n minus 1. So you have to substitute this one. I is equal to 1 plus alpha n minus 1. So 1 plus 2 here, 2 particles, 2 minus 1, 1. So 1 into alpha. So already we know that alpha is what? 0.065. So it is what? 1.065. So this is I value. You want to use the formula, that is delta T. So here they are talking about depression freezing point. So I into Kf into m. So I is what? 1.065 into Kf is what? 1.86 into molarity is already is what? 0.3264. If we multiply these three values, we are getting a 0.65 degree centigrade. That is a depression in freezing point or difference in the depression freezing point of pure solvent and the solutions. This is the answer for this case. The another one, NCERT exercise problem 2.41. So if we read the problem, determine the osmotic pressure pi of a solution prepared by dissolving 25 milligram of potassium sulfate in 2 liter of water at 25 degrees centigrade, assuming that it is completely dissociated. So you got, this is a keyword for this while solving the problem. So you got to see this one. It is completely dissociated. That means you ought to write that one. K2SO4 dissociate into what? 2K plus SO4 2 minus. So if we see the number of particles 2 plus 1 which is equal to 3, that is the I factor. Here the keyword is what? Completely dissociated. You have to find out the I value is 3. And write the data, given data. What is W2 is given in the milligrams. So 25 mg is there. You converted to grams, 0.025 grams. And the volume is given as 2 liters. And the temperature is also given as 25 degrees centigrade. So you have to convert it to Kelvin scale by adding 273 which is equal to 298 Kelvin. And the molecular mass is also given. So for the K2SO4, for K it is 39, sulfur is 32 and oxygen is 16 into 4. If we add all these things, we are getting a 174. Okay. Then you have to substitute the formulas. Pi is equal to I into C or T. The concentration is nothing but W2 by M2 into 1000 divided by V ml into RT. So R is also given as R is a constant value 0.0821. That value you have to use it. Substitute these values. Pi is equal to I is 3 into W2 is given as a 0.025 grams by the M2 is also 174 into 1000 by, if it is expressed in ml, then 2 liters you have to express as a 2000 ml. Into R is also given as a 0.0821 into T is also given as a 298 Kelvin. You have to simplify this one. This is nothing but 1 by 2 and you have to simplify this problem. The answer will comes about 5.25 into 10 to the power of minus 3 atmospheric pressure. That's pi is expressed in atmospheric pressure. So this is the answer for this problem. If you have any doubt, please mention the comment box. Thank you, students.